Hello friends, my name is Kinjal Bhavsar, lecturer in EC department from VPMP Polytechnic College. Subject name Principles of Electronic Communication. Unit name Introduction to Communication System. And topic Modulation. These are the objectives. First, what is modulation? Then, why we need modulation in communication system? Then at last, advantages of modulation. First of all, introduction of modulation. That means to regulate or adjust some parameters. Some parameters, that means key amplitude, frequency and phase. Okay. Then modulation process is done at transmitter side. Then next, definition of modulation. So modulation, that means key process in which parameters like amplitude, frequency, phase of the high frequency carrier is changed with respect to instantaneous amplitude of information signal. That is a modulation. Then information signal is shifted from low frequency to high frequency for using modulation process. Then need of modulation. So baseband signal, that means key information signals are incompatible for direct transmission over the medium, and therefore we have to use modulation technique for the communication of baseband signal. That is a need of modulation. Then advantages of modulation technique. So modulation technique, first, reduce the height of antenna, and second, it avoid the mixing of signal. Then increase the range of communication. Fourth, allow multiplexing of signal. Fifth, it allow adjustment in the bandwidth. And sixth, it improvement of quality of reception signal. Then next I will explain detail of these advantages. First, reduce the height of antenna. So height of antenna required for transmission and reception of radio waves in radio transmission is a function of wavelength of frequency. That means minimum height of antenna is given as a lambda by 4, where wavelength lambda is given as c by f, where c is a speed of light and value of c is equal to 3 into 10 raised to 8 meter per second, and f is a frequency. Next, for example, our baseband signal is frequency of 15 kilohertz. That means height of antenna lambda by 4. Then in this equation put the value of c and f that means ki 15 kilohertz. Then find out the height of antenna. Then height of antenna is 5000 meters. That means ki 5000 of height of vertical antenna is unthinkable and impractical. That's why if we consider a modulated signal and frequency of that signal is 1 megahertz, then find out the height of antenna using lambda by 4 equation. Then height of antenna is 75 meters. Then this height of antenna is practical and such a antenna can be installed. That's why modulation is necessary to reduce the height of antenna. Second, avoid mixing of signal. In all sound signal are concerned with the range from 20 Hz to 20 kHz. That means transmission of baseband signal from various sources causing the mixing of signal, and then it is difficult to separate at receiver end. Then to separate the various signal, it is necessary to translate them all the different portion of electromagnetics. Each must be given its own bandwidth known as a channel bandwidth. Then bandwidth can be achieved by taking different carrier frequency for different signal source. Then once the signal have been transmitted, a tune circuit at receiver end select the portion of electromagnetic spectrum it is tuned for that. Therefore, modulating different signal source by different carrier frequency avoid mixing of signal. According to this diagram, here three signals, signal 1, signal 2 and signal 3. Frequency of signal 1 is 20 kHz, signal 2 is also 20 kHz and signal 3 is 20 kHz. Okay. To avoid the mixing of signal, first signal 1 is connected means modulated by carrier of 100 kHz frequency signal. That means in channel 1 here carrier frequency is 100 kilohertz. That means for bandwidth lower 3 dB frequency is 100 minus 20, that means ki 80 kilohertz, and higher 3 dB frequency is 100 plus 120, that means ki 120 kilohertz. This is the channel 1 bandwidth. Same for second channel, signal frequency is 20 kilohertz but carrier frequency is 200 kilohertz. That's why 200 minus 20 to 180 kilohertz is a lower 3 dB frequency, and 200 plus 20 220 kilohertz, this is a higher 3 dB frequency in channel 2. Then same as for channel 3, modulated carrier frequency is 300 kilohertz. That means using this method modulation to avoid the mixing of signal. Next, increase the range of communication. Okay. At the low frequency, radiation is poor and signal get highly attenuated. That means our baseband signal is low frequency signal. Then baseband signal cannot be transmitted directly over long distance because this signal is low frequency signal. Then modulation effectively increase the frequency of signal to be radiated and thus increase the distance over which signal can be transmitted faithfully. Fourth, allow multiplexing of signal. So modulation permits the multiplexing to be used. Multiplexing means transmission of two or more signal simultaneously over same channel. As an example, number of television channel or radio station operating simultaneously. Then different signal from different station can be separated in the receiver since the carrier frequency for these signals are different. Then it is known as a tuning the receiver to the desired station. By tuning process, the desired signal is selected and at the same time other unwanted signals are rejected. Then fifth, allow adjustment in bandwidth. So bandwidth of a modulated signal may be made smaller or larger than the original signal. Then signal to noise ratio in the receiver, which is a function of signal bandwidth, can thus be improved by proper controlling of bandwidth at the modulating range. Then last 6, improve quality of reception. So in signal communication using modulation technique such as a frequency modulation, pulse code modulation reduce the effect of noise to great extent. That's why reduction in noise improve the quality of reception at receiver side. Thank you.